Dear students, today we are going to see basic proportionality theorem. This is also we write as B.P.T. The theorem states that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. First we draw the figure. Here we will find that triangle ABC is a triangle, a line parallel to a side. So here BC is the side of the triangle and PQ is the line L you can say is parallel to side BC. A line parallel to a side of a triangle intersect the remaining two sides in two distinct points. Here P and Q are two distinct points. Then the line divides the side in the same proportion. That means the proportion AP upon PB is same as AQ upon QC. This is what we are going to prove. So, as I told you, given in triangle ABC, line L is parallel to BC. This line L is parallel to the side BC. And line L intersects AB and AC in the points P and Q respectively. This is given. To prove that AP upon PB is equal to AQ upon QC. This is to be proved. Construction. Construction is draw say PC and BQ. This segment PC is drawn and BQ is drawn. Now here I am raising you a question. Give a pair of pairs, maybe a single pair or number of pairs of triangles having equal heights. We have seen that suppose this is a side, this is a point. From this point, if you have a triangle like this, if you take a point here and join this, join this, then this is A, B, C, D. If you consider triangle ABC, ACD or ABD also, all the three triangles, they will have the same height, the perpendicular from the vertex to the opposite side. This is the height of all the three triangles, triangle ABC also, triangle ACD also, and triangle ABD also. That is, in general, you can say that if the bases of the triangles are on the same line and the vertex is same, A is the same vertex, then the triangles have same height. You will find here the same thing, situation is same, only that this BCD was horizontal, yes. So here you are having some slant. This APB is a slant side and Q is a vertex. So from that, if you see AQP, PQB, so they are having the bases AP and PB on the same line, and Q is the common vertex, and therefore you will find that the perpendicular from Q to AB will be their height. All will have same height. Triangle AQB, PQB, and AQB also, that we may not require. Okay. Similarly, if you consider triangle APQ and PQC, these two triangles, this triangle and this triangle, you will find that the bases AQ and QC are on the same line and P is their common vertex, and therefore the perpendicular from P to this line will be their height for triangle APQ also, for triangle QPC also. So if you want pairs of triangles having equal heights, this we are requiring. APQ and PQB is one pair we are going to require in this theorem. Second is APQ and PQB is another triangle. So they are having equal height, same height, and therefore ratio of their areas will be equal to the ratio of their bases. That is what we are going to use. Second question would be this: give pairs of triangles having equal base. Now, if PQ is taken as the base, then PBQ and PCQ, these two triangles are having same base, equal base. Okay, there may be some more also. On the base PQ there is PQA also, but that we are not requiring in this theorem. So you may ignore that. And now third question is give pairs of triangles having equal height and equal base. So if you remember all these three questions, this theorem you can write, you can understand. So here having equal height. Now you know that, see here, they are given PQ is parallel to BC. So if you consider triangle PBC, the height is this. Sorry. The height is this. And also for the triangle QBC also, the height, if you consider, the height is this. But since the line PQ, this line L is parallel to BC, therefore this is equal to this. The perpendicular distance between parallel lines remains same everywhere. If you want a pair of triangles having equal height and equal base, if you consider PQB and PQC, they are having same base PQ, and since they are between the two parallel lines, PQ is parallel to BC, and therefore their heights are also equal. So these three things we are going to use in this theorem. So let us see how they have proved. So proof: triangle APQ and PQB, APQ this triangle and PQB is this triangle, have equal heights, as I told you, because their bases AP and PB are in the same line and Q is the common vertex, and therefore the perpendicular from Q to AB is their height, that is the common height, and therefore ratio of the areas, area APQ upon PQB, APQ upon PQB is equal to ratio of the bases AP upon PB. Similarly, APQ and PQC, if you consider APQ and PQC, these two triangles, their bases AQ and QC are on the same line, and the P is the common vertex, and therefore ratio of their areas is equal to ratio of their bases. Base of APQ is taken as AQ and base of PQC is taken as QC. This AQ and QC are the bases which are conveniently taken here. Now consider here what we want to prove. We want to prove AP upon PB is equal to AQ upon QC. Here AP upon PB we got. Here AQ upon QC, and here AQ upon QC we got. Now we have to show that these two are equal, and therefore we have to show that the left hand sides are equal. We have to show that area APQ upon area PQB is same as area APQ upon area PQC. You will find that to show that Here numerator is same as this numerator. Therefore, our aim would be to show that the denominators, this PQB and PQC, they are equal. So here I had told you before that if you consider PQB, triangle PQB and triangle PQC, these two triangles, they are having the common base PQ and their heights. Height is the distance between the two parallel lines, that is same. So their bases are common and heights are equal, and therefore areas are equal, PQB and PQC. That is what they have written here. So sec PQ is common base of PQB and PQC. Sec PQ is the common base and sec PQ parallel to BC. Hence, PQB and PQC, triangle PQB and PQC have equal heights also, and therefore their areas are equal. Now you will see that in 1, what we said, APQ, area APQ upon area PQB is AP upon PB. In 2, what we said, area APQ upon PQC is AQ upon QC. This is 2. And in 3, what we said, there PQB and PQC, these denominators are same. So from this we conclude that AP upon PB, area APQ upon area PQB is same as area APQ upon PQC. This area APQ, area triangle APQ upon PQB is same as area triangle APQ upon PQC. I told you here APQ and APQ, their numerators are same and denominators we proved to be same. This area is equal to this area. So these left hand sides are equal and therefore these right hand sides are also equal. Therefore AP upon PB is equal to AQ upon QC.